everybody, my name is Stuart Smith. Today I'm going to be doing basic forging on a knife made from a piece of W2 tool steel. This demonstration goes specially to my Greek friends on Hephaestus Forges. So enjoy and let's get through this quite quickly. First thing I'm going to do is I'm going to put a tip on this. Now you can see it's already been rounded. If it's a square piece of steel, you should round it first. So we're going to round it, we're just going to put a tip on it. Once the tip is on, you can see it's mushroomed a little. We want to flatten that. Now the lines are parallel once more. We're going to put it back in the fire and we're going to start tapering it. Pause. Right, now you see on this knife we've got what we call a distal taper. It's thick at the back, it gets thinner towards the front. We're now going to forge this distal taper into the piece of steel that we have. Taper. Okay, now I'm going to start forging the bevels. Alright, right now we're going to forge out the choil. The choil is the part of the knife where the edge begins. First thing we do is forge a little heel out on the knife. Make sure it's in the middle. This determines our center line of where the rest of the edge bevels must lie with regards to the center of the blade. What we're going to do with the piece that we've got in the fire, you'll see it leans this way, like a Wharncliffe style. By forging the edge gets longer and the back will straighten itself out. First thing we do is we establish where the choil is going to start. Then we start forging it out. Evenly on both sides. There you go. Now you can see what we call the heel. We now created this heel on the knife. This heel is the official term is the choil. Now once I've done that, I've established, made sure it's in the center. Now all I do is I follow that line, I forge out the rest of the blade. You'll notice I'm forging on the flat side. Because this piece of steel now elongates and gets longer, it's going to bend upwards. Okay, so now we're going to forge out the edge bevel. Now, to even out the surfaces so you don't leave deep hammer blows, forge in a concentric pattern. Forge along the edge, up the middle, then round the back. Don't hammer on the back directly, otherwise you're going to make your piece of steel too thin. Okay, so little hammer blows. Along the edge, up the middle, down the back. Okay, you can see it's nice and even. The surfaces are flat. But now, like I said, because of the extension of the material along the edge, the blade is bending. We're going to put it in the fire and we're going to straighten it now. Okay, so there are two ways you can straighten it. One is by putting it on the back like this. Don't worry about the edge buckling, you can straighten that just now. The other one is by putting it over the edge of the anvil like this and hitting it. But that usually works if this piece of cedar is solid. But because of the weld here, it's going to bend. I very quickly restored the edge there. I'm going to forge it out once more. It's going to bend a little bit, then I'll straighten it again. So I'm forging out the edge again. Okay, now you can see the edge is a bit wobbly. I'm going to even that out. And I'm going to put a tip on it. Point anyway. Okay, one more heat. You'll notice now that the temperature of the blade is not as hot. Pinching the tip between the hammer and the anvil, which gives me a nice point. It's easy enough to grind the point in, but if you can hammer it in, why not? Okay, now I'm just checking for straightness before I tackle the tang. You'll notice this piece here is not as neat as it was when we started. I am going to fix it, but only after I forged out the tang. Now the next thing I have to do is break it off. I'm going to heat this so I can forge out the tang. Alright, now we're going to put a notch in using the back of a set of tongs. There we go. And now I can start forging that out as the tang. I'm going to start forging this out by hand, just to show you how it's done. It has to be done evenly. You have to do 4 strokes or 5 strokes on one side, and you have to do 4 or 5 strokes on the other side. Always turning the blade. Now from here, we will have to carry on forging it out, but in the interest of saving time, I'm going to put it in the press when it's hot again, and we're going to draw it out quickly there. Put a slight taper in the tang, much like you did in the blade. Okay, now the tang has been done. I'm going to just straighten and even it out by hand. We're also going to put the angle in. We're going to neaten up the choil, all by hand. There's only so much you can do with a power tool. The secret to good forging is always in your hands. I'm going to neaten up the choil. Do that by putting it on the table of the anvil. Just softly tapping it, squaring it up. Then we turn it around. Then We just tap it with the hammer again to neaten it up. Make sure it's still in the middle. Nice and straight, tapers in. Okay, now we're going to straighten out the tang and neaten the tang up. You can see there's a slight bulb on the tang. I'm going to forge that out. How I want it. Now I just must make sure everything's straight. Always check on both sides. Okay, the tang is straight. It's at the correct angle. I'm going to check the blade now. The edge is in the center. There's a little bit of a warp on it. The blade is hot enough that I can forge it cold to get it straight. Perfect. I'm going to normalize it once. I'm going to normalize the blade once. Normalizing is de-stressing from the forging process. We heat the steel till it becomes non-magnetic. Not too much higher. If you heat the steel too hot, it causes grain growth and crystal growth within the steel, which makes it brittle. So we're going to take the magnet here. And I'm going to run it over the magnet. Now you can watch me. Now, when you're forging multiple blades, you can put one blade in, forge one blade, put the next blade in, forge the next one when it's hot. Never do more than two at a time, because a piece of steel that sits in the forge for too long will get too hot, it will cause grain growth and your steel will become brittle. It can be fixed, however, if you do multiple normalizing cycles, but we want to avoid that because it tends to become a waste of time if you don't focus and concentrate. Now you can see here the steel is heating up. It's got orange along the edge, but because the material is thicker along the back, creates a heat sink, we want to get that heat nice and even. Now there's a hole on the other side of the forge. I put the tip through to the other side. Because the tip is thinner, it heats up faster. By putting it through the other side, it's actually not receiving a lot of heat, allowing the ricasso, that's the thick part of the knife just before the tang, to heat up faster. We've got nice even heat. It doesn't stick to the magnet. I will now repeat that 2 more times before I take it for grinding. You can also anneal the steel. Annealing is softening the steel. I will leave it in the forge overnight and plug up the forge after I've finished using it. The slow cooling will cause the steel to soften, which makes it even easier to work if you want to do file work or anything fancy on it. There you go. That's a forged knife. To all my Greek friends. Also thanks a lot to Joey Cordova, who sent me some really nice handle material which I intend to put on this nice piece of W2 steel.